Hi, this is Karen O'Brien, and I am going to try to address a question that I received this week about setting up the rain area reduction, the RainARF reduction factor for rainfall, which is a depth area reduction for rainfall. So basically, if you have rainfall on your grid system, you might have something like isohydal contours, or like in the US, I have show you a method on how to do this or assign this using a raster. Isohydal contours are probably the most common thing that you would see, and they would give you complete coverage of a map. So if you had an isohydal contour map and it was, say, a shape file, you could download it and you could rasterize it using the processing toolbox right here, and just put in the rasterize and use this guy right here, vector to raster, if you have grass installed. And if you don't have grass installed, use this one right here. So I wanted to show you this method, but from a little bit simpler perspective, because I don't have any isohydal contours. So I just built two polygons into this RainARF areas, and then I was trying to develop a method to get that data into the export table. And I was kind of struggling with that, so I'm just going to kind of go back to the original method of developing and just converting this data into a raster. So first, before you do that though, you have to have a full coverage of the map to represent the 100% value of the rainfall, and then these guys represent the spatially variable value. I have 0.2 assigned to this one and 0.3 assigned to this one, and then I'm going to assign a 1 to the comp domain. But before I do that, I have to combine these two layers, and in order to do that, you need a union. So here's a union, and because I was activated on RainARF areas, it's already brought up into the input layer. So for the output layer, you just need to assign the comp domain. So I'll just open that up and hit the C key, and that will take me right to the C's, and then I'll just pick up the comp domain. And then I just click run because I don't have to do anything else, and now we're finished with this. And it creates a scratch layer, meaning that it's a temporary layer and it will go away once you close the map. If you want to keep it, you can just save it as a shapefile. Now I want to get into the attributes of this layer because I need to add 1 to the base polygon. Now as soon as I do that, I'll get back out of here. Let's see, I need to save that. So hang on a second, save. I don't know if you notice it, but if you edit a field and you have to get out of it for the edit to allow you to hit a save. Okay, so now we have ARFs of 0.2, 0.3, and 1, and so if I click on the point, the new one, you see right here that that is the 1, that all those cells that are intersected with that would get a value of 1, and then all of the cells that are intersected with this polygon get a value of 0.3 and 0.2, etc. So but we can't use this in this form either. We now have to rasterize it. So if I come back to the toolbox, I can rasterize this, and I can grab the V to rast tool, and it's already on union because that was my active layer. And I need to use the attributes to build the raster. So this is attributes. This can go to ARF, and then this is important. You don't need to worry about any of these, but this one's important. It needs to be set to grid. So if I calculate from layer and I set that to grid, and then this one can be this is the pixel size, so I'm just going to say 30 because that's my cell size, so that makes it easy. And then I'll click run, and now it's finished, so I'm going to click close. And if I turn off the comp domain, you'll see that this raster has a band. It starts at the lowest 0.2 in black and 1 in white. So if I hit my ID tool on this right here, my ID tool, and I click on it, you'll see that indeed that rasterized perfectly. So now we can just use this raster to set our rainfall values. So back to the Flow2D widget, and all we need to do is make sure that this box is checked and click this button here, and this was automatically assigned to rasterize because it's the first in the list, not because it's the active layer, but because it's the first in the list. And just like the elevation or any other rasterizing process, you just need to set this to 0.9999. Actually don't need this value unless I need to do fill no data. But I don't need to do fill no data, so I don't need to set the source no data value. And then this can be set to maximum because you want the maximum rainfall, not the average rainfall along the boundaries of these guys. Click OK, click yes, and that will overwrite the data that was already in there from the last time I did this. Now I want to export the file, so here is my lesson 1 export, and I want to export this, but I don't need the whole thing. I just want to check it, so I don't need the whole thing. So I'll just get the rain, and when you just select one file, you always get the cont and the taller, of course, that's default, but you also get the rain. And I need to save this actually because I'm tired of having to expand that every time. Okay, and you see that here's your rain.dat, here's your 5 inches of rainfall, and this switch indicates that you do want to use the depth area reduction for rainfall. This is your S curve. It's just an SCS 24-hour type 2 curve, and then after the S curve you have the individual RainARF factors. Now I will say right offhand that these factors, if you have a 1, that doesn't even need to be in the list, but if it's not there, it's automatically going to get 1. So if the grid element isn't listed, it's automatically going to get 100% of the rainfall. And then anything that the spatial variability comes with the other grid elements that are listed. So it's okay if it's in here as a 1, that's perfectly fine. And then if you control F on this and you set that to 0.2, which I'd already done it, whoops, sorry, I'm looking in the wrong direction. I need to look down. Find next, and you can see that you have some 0.2s. And if you have a 0.3000, whoops, sorry. And then you can see that you have some 0.3s, but this one looks a little funny because my polygon on that polygon went down into a point, so it was only covering a single cell. So the first 0.3 is probably only going to be 1, and the next one might be 2 or 3 or whatever, and then they'll expand as the map progresses from the west side of the map to the east side of the map, because that's how the grid elements are numbered. They are numbered north to south and then west to east. That's just the standard way that QGIS numbers your grid. And so that's how you can get rasterize a polygon layer and convert it into a RainARF areas. Because what the raster does, or sorry, excuse me, what the algorithm does, it's very simple. It just takes this value over the maximum value, and that becomes the depth reduction factor. And so this number, the number that is assigned in this raster, is not super important as long as the ratio creates the factor, as long as there's a max that represents the maximum rainfall, and then of course the spatially variable that sets up the factor. So this can be 0.2 as long as this is 1. Or if you have isohydal contours, this might be one of the contours might be 5 and another contour might be 4.8 or something like that. And so the 4.8 over the 5 then becomes your depth reduction factor. So that's how the calculator works. It's pretty nice in that regard because you can use any kind of data and it doesn't matter really what the units are or anything. Alright, so if you try this out and you get stuck, please let me know. Karen@flow-2d.com is my email if you need some help on this. Otherwise, I hope you enjoy the process.